Midsummer in the Chilean Atacama Desert. As night falls, telescopes at ESO's observatories are just starting the night's observations. But all of a sudden, a strange phenomenon appears in the distance. What could this be? Let's take a closer look. This is the ESOcast. Cutting-edge science and life behind the scenes at ESO, the European Southern Observatory. It's the 20th of January 2015 and ESO photo ambassador Petr Horálek is capturing the beauty of the Milky Way at the Lars Observatory. Suddenly, a series of short-lived flashes of red light appear out of nowhere above the horizon. At the same time, almost 600 kilometers away from Lars, a cluster of massive thunderstorms is raging over northern Argentina. Pointing his camera in the direction of the flashes, Petr photographs the very rare and peculiar features known as Red Sprites. This makes him one of a small group of people to successfully record them, and it's the first time that they have been captured from a major astronomical observatory. A week later, Petr travels further north to photograph the night skies above ESO's Paranal Observatory. Just a few hours before daybreak, he once again witnesses a flurry of these strange flashes over the Andes. From Petr's perspective, they appear to come from the direction of the rising galactic bulge of the Milky Way. But they actually originate from another huge complex of storms over Argentina, more than 600 kilometers from Paranal. The storms are so strong that Petr can observe and document another display of their activity. High in the atmosphere, gravity waves are generated by these storms and form ripples in the greenish layer of airglow. But what are these curious airy spirits? In thunderstorms, most cloud-to-ground discharges are called negative lightning, as they transfer negative charges to the ground. Barely 5% of all discharges are positive cloud-to-ground lightning, transferring positive charges from the thundercloud to the ground. Up to 10 times more energetic than negative lightning, positive lightning seems to be what makes the Earth's atmosphere a playground for red sprites. Red sprites are a manifestation of complex high-altitude electrical processes. They appear, dancing in the dark night skies, as red figures composed of beads, puffs, and tendrils of light. These unusual flashes are formed at altitudes of up to 90 kilometers and get their distinct red hue from the excited nitrogen molecules in the atmosphere. Red sprites were first suggested on theoretical grounds in 1925 by the Scottish physicist Charles Wilson. But it wasn't until 1989 that scientists from the University of Minnesota managed to capture the first image of a sprite on film as they were photographing aurorae. And just a few years later, the NASA Compton Gamma Ray Observatory managed to discover gamma bursts originating above thunderstorms, another consequence of lower atmospheric lightning activity. Astronauts have a particularly good vantage point from space and have also photographed sprites using normal digital cameras. From space, sprites appear shortly after their corresponding lightning strike. In this image taken from space, Both the sprite and the lightning flash are captured. There are many different species of high-altitude atmospheric flashes on Earth, commonly known as upper atmospheric lightning. Scientists have even speculated that similar phenomena could occur on other planets in the solar system. Red sprites might be the most frequently photographed upper atmospheric lightning phenomena on Earth, but they can appear rather dim when captured on camera. Furthermore, the exact time and location of their appearance in the sky is quite unpredictable. They have been found to show up over powerful and large thunderstorms, but only for a fraction of a second. These factors make them very hard to document and study. Red sprites remain mysterious, and any new image showing them is valuable to scientists trying to study these elusive spirits that dance above thunderstorms. And now ESO has also contributed a small piece to this intriguing puzzle in the Earth's atmosphere.